Hello everyone and welcome. Have you ever stopped to think that math can actually tell a story? Well, today we're going to see how all sorts of everyday situations are really just stories written in the language of numbers, just waiting for us to figure out their secrets.
I know, it sounds a bit like the start of a riddle, doesn't it? But the answer isn't some clever little punchline. It's actually a really powerful mathematical tool that helps us make sense of the world around us. And by the end of this, I promise you'll see exactly how these three totally different scenarios are all connected. So, let's just dive right in.
So, here's what we've got lined up. We're going to start by finding an equation hiding in a real-world puzzle. Then, we'll define the exact tool we need to solve it. After that, we'll get some practice turning more stories into math. We'll even learn how to spot these equations when they're in disguise, before, finally, putting all our new skills to work to find the answer.
All right, so let's jump right in with a super practical problem. For the next few minutes, just imagine we're architects or designers, okay? We've been given a very special project to work on.
So here's the challenge. We have a very clear goal, right? A carpet area of exactly 300 square meters. And we have a very specific design rule to follow. The length is connected to the breadth in this very particular way. The real question is, how on earth do we turn all these words into something we can actually solve with math?
Well, we just take it one step at a time. First, since we don't know the breadth, let's just give it a name. We'll call it x. Now, based on the rule, we can express the length using that same x. It becomes 2x plus 1. We all know area is just length times breadth, so we multiply them together. The best part is we know the area is 300, so we set our little formula equal to 300. And with a quick bit of rearranging, we get this. 2x squared plus x minus 300 equals 0. That right there, that is the mathematical key to our entire puzzle.
So that equation we just built, it actually has a special name. It's called a quadratic equation. Let's take a quick moment to properly define this essential tool we're going to be using.
Think of this as the standard blueprint for any quadratic equation. You've got a part with your variable squared, a part with just the variable, and then a plain number, all set to equal 0. The a, b, and c are just placeholders for the actual numbers from our story. Like the 2, the 1, and the negative 300 we just found. So, what really makes an equation a quadratic? Well, there are a few simple rules. First off, the highest power of your variable, our x, has to be 2. That's what the quad is all about. Now, the second rule is simple. A, b, and c are just normal numbers. And this is the big one, the most important rule of all. A, the number in front of x squared, can never ever be 0. Why? Well, think about it. If a was 0, that whole x squared term would just disappear, and we wouldn't have a quadratic equation anymore. And you know what's really cool? These equations are not new at all. People have been wrestling with these kinds of problems for thousands of years, all the way back to ancient Babylon. In fact, ancient Indian mathematicians made some huge breakthroughs. Brahmagupta gave us a general solution way back in the 7th century, and later, Sridharacharya derived the famous quadratic formula that's still used in classrooms all over the world today. It's just a great reminder that math is this beautiful global story built over centuries.
Okay, so now that we've got the theory down, let's get some practice in. We're going to take two more little stories and translate them into that clean, precise language of quadratic equations.
Let's use that same step-by-step thinking for this marble problem. The logic is exactly the same. First, let's just say John has X marbles. Since they have 45 in total, Javanti must have 45 minus X. Then, the story tells us they each lose 5 marbles. And for our final clue, the product of their new number of marbles is 124. So we multiply their new totals, set it all equal to 124, and after a little bit of expanding and rearranging, there it is, back in that familiar standard form.
Okay, one more time with the toy factory. Are you seeing the pattern here? We let x be the number of toys. The cost of each toy is described as 55 minus x. The total cost is just the number of toys times the cost per toy. We know that total was 750 rupees, so we set up our equation. A little bit of algebra later, and boom, we've modeled another real-world scenario. It's the same logical process every time.
Okay, so we're getting pretty good at building these equations from scratch. But what about spotting them out in the wild? Sometimes an equation might try to trick you. Let's learn how to do a quick identity check. This is where you have to put on your detective hat. Okay, look at the equation on the left. At first glance, that x to the power of 3 makes you think it's a cubic equation, right? But watch what happens when you expand it and simplify everything. The cubic parts actually cancel each other out, and what's left is a true quadratic in disguise. Now look at the one on the right. This one definitely looks quadratic, but again, when we simplify it, the x squared terms completely disappear, leaving us with a much simpler equation.
So, what's the big takeaway here? It's this. You absolutely cannot judge an equation by its cover. You have to do the work and simplify it first to see what its true identity is. It's really the only way to know for sure if you're dealing with a quadratic or not.
All right, we've learned the theory, we've practiced, we've learned how to spot them. Now it's time for the payoff. Let's go all the way back to that very first problem and finally solve the mystery of the prayer hall dimensions.
Remember this guy? This is the equation we so carefully built from the Charity Trust's plans. The answer to their question, the actual dimensions of the hall, is locked away inside this statement.
So when you actually solve this equation, and we'll cover how to solve them in another explainer, you get two possible answers for x, 12 and negative 12.5. Now mathematically, both answers are correct, but this is where we have to use our common sense and bring it back to the real world. Can the breadth of a room be a negative number? No way. Of course not. So logic tells us we can just throw that negative answer away.
So that leaves us with only one logical answer. The only solution that makes any sense in the physical world is 12. The breadth of the prayer hall has to be 12 meters. And because we know the rule for the length, that it's one more than twice the breadth, we just pop that 12 back into our little formula. So 2 times 12 is 24, plus 1 is 25 meters. And there you have it. We went from a story problem all the way to a concrete, real-world solution. How satisfying is that? So what have we really seen today? That from building plans to games with marbles, quadratic equations are this hidden language that helps us describe and solve problems all around us. It really makes you wonder, doesn't it? What problem in your world, big or small, is just a story, waiting for you to find the right equation?